when PCB layout was easy and even kind of fun? Yeah, those were the good old days, right? You just threw down a big old power and ground plane and connected everything that needed juice up to that. And you didn't have that many nets to connect up, so you could do kind of little art projects with the traces to amuse yourself. And then all that fun came to an end. Hey, Amelia, that design you just did has some serious issues with power integrity, and we think it's just a board layout issue. Oh, and also, Amelia, some of those signal traces you laid down are causing timing problems, particularly this one that, well, kind of looks like a grumpy cat. Dang. Hello, power and signal integrity. Goodbye, PCB trace art. Hi, I'm Amelia Dalton, host of Chalk Talk. In today's complex PCB design, signal and power integrity can be a real challenge. My guest today is Brad Griffin of Cadence Design Systems, and we're going to look at signal and power integrity from every angle, up, down, and sideways. Before we get started, remember to click that link. There you can download a tech packet that includes a free white paper entitled How a Team-Based Approach to PCB Power Integrity Analysis Yields Better Results. And you can also download a free data sheet entitled Allegro Sigrity SI, Streamlining the Creation of High-Speed Interconnect on Digital PCBs and IC Packages. Hi, Brad. Thanks so much for joining me today.
Amelia, I'm very, very happy to be here.
Okay, Brad, we're going to be talking about signal and power integrity today. So give us a scope on what we're going to be talking about.
Signal and power integrity is a process that's been around in EDA for quite a while, but we're really having to change the game these days. And we're going to talk about how we're moving the process upstream, downstream, and sideways.
Okay, now, sounds to me intuitively that upstream would be pretty hard. So are you saying that we should all just aim for downstream?
Well, I think it makes a lot more sense to be able to take the technology, take things and move it from the front of a project to the back of a project. But we're going to talk a little bit today. There's certain cases where trying to take the technology upstream actually makes sense.
Okay.
So I agree with you that upstream is harder than downstream.
Yeah.
But if we get it right, then mostly downstream and sideways will be what we're focusing on.
Excellent. Okay.
So when we think about upstream, we're saying, are we performing analysis for the first time on that project? And so if we are at the end of a project, that's a problem.
Right.
Because it's tough to be able to fix things when you've got a very small amount of time left in the project schedule.
Yeah.
So we're going to look to find ways to move it upstream. But if we start at the beginning of a project, then yeah, that's when we can basically take analysis that we do early on and the what if types of things and put them into the design and drive those as constraints
Okay.
throughout the whole design process. And again, what we've primarily focused historically is we're focusing on designing a print circuit board. We're focusing on designing a package. But the reality is none of these things make up a system.
Right.
And ultimately, we're trying to build a system.
Yeah.
So we have to connect that PCB to the chip and to the package.
Yeah.
So instead of looking at one of those fabrics, we want to look at all of those fabrics.
Okay, so let's jump out of the water and talk about how this applies to a real design.
Okay, great. So I think there's really 4 steps to this. So we can take it in 4 different hunks. The first we're going to talk about, we have to know where we're starting from. And then we have to know where we're going to.
Right.
And then there's a lot of steps in between. So we got to know those tasks. And then ultimately, if we do all those tasks, do they fit into our schedule?
Right.
Because we got to get our product to market on time.
Yes.
Right? So we're going to look at how we can build that downstream process, starting early in the design process, from pre-design to in-design to sign-off, and then how we can spread that out between chip, package, and board.
Okay, this seems a little bit like shopping at a mall. Is that what you're saying here?
Well, it does remind me when I first go into a mall and I want to know where that Gap is or whatever.
Right.
You're looking at the sign, you are here, right?
Right.
And so I think there is a bit of a process here where when we're looking at where we're going to, it makes a difference in where we're starting.
Yeah.
And so if we're starting developing a brand new product, then we have certain things that we are looking to accomplish. But on the other hand, if we're looking in building a next generation product, then we're trying to reuse as much as possible from that existing product.
Right.
And so this is kind of where my upstream thing comes into play.
Okay.
It's like, I've got a product, it's all working, but I want to make it better.
Yeah.
But I don't want to redesign everything.
No. Yeah.
So I want to take a little piece out and plug in a new piece. And so in a way, I'm kind of moving upstream to take a new model or a new piece of technology and simulate it and see if that's going to work, if I'm going to be able to make it go faster, if I'm going to make it in a smaller system, whatever my marketing team has required me to do.
Yeah.
That's the way we look at trying to move this product upstream, because we may find that we just can't do it. We're going to have to redesign the whole thing. Might as well know that now versus at the end of the project where you say, oh, it's just not going to work.
Yeah.
But ideally, we'll find that right way to tweak it to make it work. So it is a little bit like starting at a mall, knowing what you're starting to do. You know, where am I going? Am I trying to find the Old Navy, or am I trying to build a new product? Am I trying to buy a next generation product?
All right, Brad, let's take this out of the abstract. Are there any tools that can address these issues?
Well, fortunately, yes. That's one thing that I'm really happy to say is at Cadence, for quite a while, we focused on Allegro technology, which is really a front to back flow. So you start very early building a schematic and plugging pieces together and saying, well, how are these going to perform from a signal integrity perspective?
Yeah.
So you got a very high speed FPGA, and it's got to talk to some kind of logic. And if it's going to have to connect to 5 different pieces, is that signal going to work when it gets to the 5th one? Or is it going to be all reflected and not be of good enough quality?
Yeah.
So luckily, we've had technology, a flow that many of our customers have used for quite a while with Allegro. Now, 2 years ago, we acquired a company named Sigrity, who's very much focused on that post-route analysis.
Yeah.
And so some of the technology that we had at Cadence really wasn't keeping up with this multi-gigabit world that we're in today.
Yeah.
You know, running at DDR4 3200 and PCI Express running at 8 and PCI Express 4 running at 16 gigabits per second. So now with the Sigrity technology, we're able to add that on to Allegro to really make our post-route analysis a really strong process. So there's a really good front-to-back flow for any particular fabric.
Very cool. Okay.
But the other thing I think that's also important to mention is with the Sigrity technology, we're able to build sort of an abstract model for each fabric.
Okay.
So the chip, the package, the board, we can put that all together and we can verify that any particular product is going to work. And now this is where the upstream part comes in.
Yeah. Okay.
So now I'm going to have to run this PCI Express 4 instead of PCI Express 3.
Yeah.
So basically I can take out my old chip model, I can put in my new chip model and see if it works in the same environment. If it doesn't, what kind of tweaks can I make? Because what I'm trying to avoid is having to redesign the whole product because I'm trying to go twice as fast.
Yeah.
Because the customers are demanding that I go twice as fast, but I don't want to take 2 years to get there. I want to take 2 months to get there.
Yeah.
And so the Sigrity technology really helps the individual flow for either chip, package, or board, but it really helps the process for chip, package, and board. And that's what we're really happy to say, that we've got the right tools to help get you started at any point in the design process.
Excellent. Okay, Brad, now that we know where we're starting, where are we headed?
Good question. So we take our little roadmap and we're trying to figure out what do we need to do to get our end product to market, right? And so certainly what we need to know is, are we building a system?
Yeah.
Because if I'm a systems company, maybe a cell phone company, then I have a very specific set of tasks that I need to accomplish. But we have a lot of customers that build chips. And so sometimes those chips are designated for one product, but many times they're designated for many products.
Yeah.
And so because of that, there's a lot more flexibility that somebody involved in chip design needs to consider. One of the things we see all the time is reference designs. They want to build a reference design, and if one of their customers comes to the table and says, I need a reference design where your chip is working, say you've got a big CPU or something like that.
Okay.
I need to see your CPU working in an 8-layer board, because if it takes more than 8 layers, I can't build it. It's going to be too expensive. And so there's really a lot of reason for us as a chip design company to start exploring that task early on and doing co-design with the PCB, even though I'm not actually delivering a PCB to my customers.
Right.
So you have to kind of look at this what-if world. What are people going to do with my chip? So in either case, whether you're doing an in-system or a semiconductor, the chip package board analysis is required. But I think if your destination is a semiconductor, you've got a lot more things to think about. And I think that co-design and optimizing the way your I/O and your BGA is oriented with respect to your PCB or potential PCB and where connectors might be located.
Yeah.
You really have to look at all of that so you can ultimately help your customers deliver a product to market that's going to be of minimal cost.
Okay, Brad, we know where we started, where we're going. What's next here?
Well, I think what we want to talk about is what technology do we provide that helps you no matter what your end product is, whether
Right.
it's a system or whether it's a semiconductor. I've already mentioned the Allegro technology and the whole front to back flow. What I really didn't talk about in any detail is how we've integrated Sigrity into that. So Sigrity is analysis technology that has been traditionally used in post-route. But what we've tried to do is make it the whole in-design process become much more efficient.
Okay.
We'll talk about this in a little bit more detail later on, but the idea here is that we're sort of bridging the gap between the layout person who's actually responsible for the implementation of the design and the signal integrity or power integrity expert who typically then takes the design back to a cubicle and explores it for a week.
Right, yeah.
Comes back and says, change this.
Yeah.
You know? So what we really want to do is try to make them work or give them an environment where they can work more cooperatively. And so we've integrated the technology in there and really empowered the layout person to perform sort of first order analysis that's a subset of what the PI and SI expert will do. So that's looking at an individual fabric and probably something that you'll use regardless of whether you're building a system or a semiconductor. But the other piece that I wanted to talk about is, again, if you're that semiconductor designer, that's where you really need to look at co-design. And so we have technology, and again, this is something that we got from Sigrity in the acquisition, but we've really integrated it with our packaging tools.
Okay.
And that's a piece of technology called Orbit.io. And Orbit.io, it really lets you in a very abstract way look at chip package board all in one view and then move things around, because as soon as you see like an interface on the east side on the chip, but it's on the west side on the package and it's on the north side on the board, you're okay, this is a big rat's nest. And I need to figure out how to resolve all this. And Orbit.io gives you that view to be able to sort of, what's the compromise? Mm-hmm. How can I put corner here and the corner there and make it so all these things don't have to cross over each other, ultimately minimizing the number of layers that you have to use in your package and your PCB. So really what we see is Orbit.io helps you reduce the cost of the overall system. And again, this may be the cost of your customer system if you're a semiconductor company. And then the Allegro Sigrity technology helps you maximize the performance, whether your end product is a package or your end product is the whole system.
Okay. So I think I might need some turn-by-turn directions here, Brad. Do I need a GPS, a map, a Siri perhaps? What's up here?
Yeah, I'm going to be perfectly honest with you. It's not that straightforward. There's a lot of different tasks that people need to look at. You, as a designer, needs to look at. So here I've kind of listed a set of tasks. If you're a chip designer, your customers are going to want to have behavioral models.
Yeah.
Traditionally, as things get really fast, people give like transistor level models. Well, guess what? If you're going to do a DDR4 simulation, that's not going to work, because you have to have something that you can simulate multiple bits and look at the eye diagram of that.
Right.
Package design, people need to be involved in making decisions, whether it's a flip chip that's going to be more expensive but higher performance, or whether it's going to be a wire bond package. So you need environments where you can look at feasibility and come up with different trade-offs, cost versus performance. Mm-hmm. PCB design, that's always something that's a challenge, especially as we get smaller designs, whether it's a cell phone or a tablet.
Yeah.
Breaking out of these big chips. I mean, if you look at a teardown of some of these devices, they've got big chips in them with very dense packages. So how are you going to get the signals out and still keep it on a PCB that has a limited number of layers? Mm-hmm. So there's breakout technology that you might want to use to be able to support that. And then along the lines, because you're usually trying to match the lengths between point A and point B, we have parallel bus modeling capability, call it something called timing vision, that allows us to match those lengths very easily, adding all the little bumps and sawtooths that you need. And ultimately, another task, as we've already talked about, if you're involved in chip design, is co-design. And whether that co-design is sort of modifying the locations of the bumps or modifying the locations of the IOs, or there's co-analysis, where we're looking at the next generation design where you're plugging in models to see if it's going to work with an existing design, or if it's a new design, doing all the analysis up front, chip, package, and board, and creating constraints from my what if analysis.
Right.
So there's a whole list of tasks that's part of them. So you do need that turn by turn directions, I think. And the good news is the Cadence tools are set up with workflows to give you guidance.
All right, Brad, I think we can do this. Let's dive down to some specifics now. Are you ready?
Yeah, there are tools for every one of these. And one of the tools that we talked about, or one of the tasks we talked about, was the IBIS model creation. That's a very unique tool that Cadence has. Very short name called T2B, but that means transistor to behavioral model.
Oh, okay.
And that's the really important technology that we have that sort of speeds up the analysis, right? Because you can use that behavioral model instead of the transistor level model. And then whether you're doing package design for being able to assess the package and find out quickly whether the inductance or resistance of each pin is kind of in parallel across the package, and then build a model so that can be used for analysis. There's also electrical thermal analysis that we have. So when you're looking at IR drop analysis, we're going to want to use a tool called PowerDC. PowerDC will look not just at one piece of the technology, one piece of the system, but it'll look at chip, package, board all together. And while it's doing that, it'll look at the electrical voltage drop within the context of the temperature of the system.
Yeah.
That actually takes multiple iterations to do that, because as temperature changes, the electrical performance changes. So we go back and forth and all that. And then we have a whole list of other tools, PowerSI for extraction, System SI we talked about briefly before. That's what actually performs the chip package board analysis. We have a very unique solution around simultaneous switching noise called our IO-SSO analysis suite. And that uses System SI Excite PI, which is a chip level extraction, and eventually gets to the point where it tells you, is the signal going to meet my compliance for DDR3 and DDR4?
Okay.
So there's a long list of tools here. The good news is that, as I mentioned, we have a workflow that gets you through, so you know where you started, you know where you're headed. This gives you all the steps in between.
Excellent. Okay. Now, how does this fit into my schedule? This sure seems like a lot of work, Brad.
I'll be honest, there are a lot of steps here. If you're on a tight design schedule, and I don't meet too many customers that aren't, you need to find ways to take serial tasks and parallelize them. And what we've talked about so far with chip package board, this is something that we've worked very closely with one of our customers and actually the DesignCon paper on, where they had a process where basically the whole PCB process was just knotted up there at the end. But then when they started looking at doing co-design, they were able to move much more of the PCB analysis processes up front, perform analysis, and then sort of synchronize with the package and the board in the middle. And it kind of stretched it out.
Yeah.
So they had more of an opportunity to sort of close and get ready for their final prototype. So that's one thing. Again, I'll encourage our customers to really look at how Cadence can help you with co-design. And then what we also want to look at is, how do we take this detailed analysis that we've talked about with Sigrity and be able to move that in design, not just wait to the very end.
Right.
And so we want to encourage people to use a process that allows them to perform early analysis, in design analysis, and then sign off. The more that they can look at it throughout the design process, the fewer problems there should be at the end, so you can actually meet that schedule.
Right. So, Brad, I assume you have some technology to help me with all of this? Going out on a limb there?
A very good assumption. What I would say that we put a lot of work in recently, and I touched on it a little bit earlier, is how do we sort of take these two different worlds between implementation, each of which Cadence has a long history of being a leader in that environment, and now that we've acquired the Sigrity technology, taking that sort of expert level tool and sort of combining the two.
Yeah.
So what we've really focused on is we focus on how do we empower the layout designer with some of the easier stuff that Sigrity provides. We call it our first order level analysis. And then how do we empower the experts so that when they find a problem, their instinct isn't just to throw it over the wall and say, you need to go fix this.
Yeah.
They can tinker. They can go in, they can tinker with the design and say, well, what if we change this? And what if we change that? What's the right thing to do?
Yeah.
And then ultimately, they probably don't actually make the change to the layout, but they're empowered to say, these specific changes will work. So
Yeah.
can you make these specific changes? And so there's been a lot of work both in signal integrity and power integrity to sort of combine those two job functions, if you will. Another thing is, and we give Sigrity all the credit for this, they understood very early that the trend towards running full wave 3D analysis, while that gives you the most accurate solution, it's just not practical
Yeah.
for large designs. It's just, almost for any design, it's really just focused on very complex 3D structures. That's really the only thing that you can effectively utilize that technology for. But they came up with something called a hybrid solver. And the hybrid solver gives you just about full wave 3D accuracy, but it also allows you to look at full designs.
Yeah.
And so you can actually get a job done. The idea here that the certain set of tasks in a certain set of time, I want to analyze what I can. I want to use the hybrid solver because it's going to cover as much of my design as I need it to cover, but I'm not going to sacrifice hardly anything on accuracy. Another thing that I've seen this over the years is that especially people that are the tried and true signal integrity experts, you know, somebody gives them a model for the chip, somebody gives a model for the package of the board. Then they try to figure out, well, these things all have different net names.
Yeah.
How do I hook A to B?
Right, yeah.
It's a mess. And then they try it and then everything's all discombobulated and they go back. So they end up taking weeks to actually solve a problem where the simulator could solve it probably an hour because it's all a setup problem. So Sigrity has very wisely put together something called an MCP header on all of their models. MCP stands for Model Connection Protocol. And so this gives you the net names and it gives you the pin locations, and you're almost automatically be able to connect fabric A to fabric B. And so that whole process, dealing with that complexity, is reduced down to a very small task.
Nice.
So that's, again, one of the ways that we can kind of close that gap. The other thing I would just add is there's very detailed level analysis that's required at some point in the design stage. We actually refer to that as our level 3 analysis. But you don't have to perform level 3 analysis all the time. So if you're just looking to see, is my signal integrity okay? Do I have any reflections? Then level 1's fine.
Yeah.
If you're looking at my high-speed signals, are they interfering with other signals on the board? Looking at crosstalk, that's what we call level 2 analysis. And so you can do that in sort of a traditional signal integrity environment, and most signal integrity tools support that. And so that level 3 analysis is your very detailed analysis, which you're only going to need to look at sort of as a sign-off solution. And we particularly refer to simultaneous switching noise. Like in a DDR4 bus, if you're switching all 64 bits simultaneously, you need to have signal, power, and ground all coupled together to really establish timing closure. So we try to give you the level of analysis that you need at the stage of the design cycle you're in. So you can do those early tasks and get 60, 70, 80% of your answers. And then the sign off, that's when you do the detail analysis. And yeah, you're going to pay a little bit of a penalty in time to perform it, but you need it for timing closure. So you have to schedule for it, but the fact that you're able to cover so much more earlier without going into that detail, it really helps you close the schedule gap.
Gotcha. Okay. So, Brad, give us some more details about signal integrity in particular.
Yeah, so I think what I hope to talk about is how we've bundled all the signal integrity analysis that we got from Sigrity and combined it within the Allegro environment.
Yeah.
So Allegro, as you know, it's a board layout or a package layout environment. You see all the traces on layer 1, 2, 3, 4, how many layers you are. And then you need to be able to perform some level of analysis on that.
Yeah.
And there's also a constraint-driven environment that supports that. So as we talked about upstream, being able to create those constraints, drive it in the design, Allegro supports all of that. So what we've done is we've created an analysis version of Allegro called the Allegro Sigrity Signal Integrity Base product.
Okay.
That's where you perform your first order analysis. As I mentioned, bridging that gap between the layout designer and the SI expert. The layout designer kind of lives in the SI base.
Okay.
All right. And now the experts will use these options that sit on top of it. Power integrity, power aware SI, that's for memory interfaces. Serial link is for things like PCI Express. And then package assessment and analysis, that's for someone who's involved specifically in package design.
Gotcha.
So maybe one thing that makes sense to talk about is the base product supports either PCB or package.
Okay.
And so that's kind of created an environment where if you have a specific problem you're trying to solve, you'll take the base plus that option for that problem.
Right.
And it makes it so you can acquire the technology in a sort of a cost-effective way versus that laundry list of point tools that I was giving to you earlier. So
No,
just buy
thank you.
basically 1 or 2 products instead of having to buy 10 products.
Right. All right, Brad, let's talk about the other half, power integrity.
So power integrity has actually been an interesting thing for us because prior to the Sigrity acquisition, Cadence had some power integrity technology, but it wasn't ever very well adopted. So we actually made one of those hard decisions that an acquiring company has to make, and we scrapped it all. And so now what we've done is we've taken sort of the foundation of a tool that Sigrity has called Power DC, which provides IR drop analysis, and we've kind of bolted it on side by side to an Allegro floor planner.
Oh, okay.
So now what you're able to do in our base power integrity solution, again, this is the environment that we think the PCB or package designer will use quite frequently. You can run the IR drop analysis. You'll see a big red spot. You'll zoom into that on the red spot. Well, guess what happens in the floor planner? It zooms into the exact location.
Nice.
And you can see, oh, I've got a bunch of vias there that are blocking return current. So that you can start moving things around, and you can help very quickly have this back and forth between the floor planner and the DC analysis environment and help you resolve those issues. And again, our focus here is that the point that the layout designer hands it over to the expert, he's handled the majority of the problems.
Yeah.
So you don't have as many iterations between expert and layout designer.
Excellent.
And then, of course, then we have the full Sigrity suite of power integrity tools, which perform decoupling capacitor optimization. We even included a 3D field solver in there, so you can have a very accurate full wave extraction. These are all the sort of things that your power integrity user wants to use. Also, a very popular tool called Power SI is part of that environment for doing AC analysis. So AC, DC optimization, those are the 3 main features that are in that option. And we really look at that as the expert's tool. So when he finds a problem, guess what? He still has access to the layout design. So if he wants, he can make little edits, tinker with it, and then feed that information back to his PCB designer so that we can get it right and reduce the amount of time that we spend actually doing power integrity analysis, get it out the door.
Excellent. Okay, Brad, I think I may need some more coffee and a recap. So could you give me your main points again, if you don't mind?
Right. Amelia, thank you very much for this opportunity. So what I really hope to try to articulate here is that there's a process that we need to go through.
Yeah.
And the sooner that we can start in the design process, the better. And so we've provided a number of what-if analysis tools to drive constraints into that design process. But we have to remember, our chip, our package, our board, it doesn't live in a vacuum.
Yeah.
It lives amongst other chips, package, and boards on either one or more PCBs.
Right.
And so we're looking at trying to do system-level analysis with whatever level of detail that we have in the various different design processes. And so we have the system-level signal integrity and system-level power integrity solutions available to be able to look at that. And really, modern electronic design requires that integrated analysis across multiple fabrics. And to meet schedules, we have to have design and analysis integrated.
Gotcha.
So we've been focused on building these advanced solutions and integrating them with our package and PCB tools. And our Allegro Sigrity, signal integrity and power integrity design and analysis solution, we really believe this is going to provide the resources that whether you're designing a chip or whether you're designing a system, that you're going to be able to get it right the first time.
Sounds good to me. Well, I think that's all I have time for. Thank you so much for joining me, Brad. It was a pleasure speaking with you.
Always a pleasure, Amelia. Thank you so much.
Before we go, don't forget to click that link. There you can download a free tech packet that includes a white paper and data sheet that further expand on this topic. For Chalk Talks, I'm Amelia Dalton. For more Chalk Talks, head to EE Journal's YouTube channel or the on-demand section on eejournal.com.